How has seasonal climate changed in the Northwest over the last century? What can we attribute to natural versus anthropogenic factors? And how will climate evolve over the next half century? These are all questions that we face, whether in the context of managing agricultural productivity, thinking about water resources, or thinking about the lives in the future of our children and grandchildren. Fortunately, your REACCH team of climate scientists have some answers to these questions. And with your help throughout this project, we're hoping to integrate some of this knowledge to help guide our decisions on how to adapt to future climate. The first question that we actually ask is, how has climate actually changed regionally across the Northwest? In the Northwest here, we're looking at a larger scale than just the REACCH domain. It's basically Oregon, Washington, Idaho, and western Montana. And we can look at temperature and precipitation through time and through various data sets. And what we see in looking at any climate data set is that we see a lot of noise, a lot of variability on a year-to-year basis, which sometimes is perceived as a lack of climate change. But if you look at any sort of data set like this for temperature, what we see is an increase through time in annual temperature. And more interestingly, we see this sort of non-monotonic increase through time. If we look at trends through time, if we look at trends starting in 1900, 1910, 1920, whatever time period you want to look through, and end the data in 2011, what you see overall is a preponderance of warm colors. These are indicating positive trends. And moreover, you also see that trends have actually increased through time. And this is pointing towards an acceleration in warming across the region. The one main exception, of course, when you look at this plot here, is spring. And spring from 1980 to 2011 has actually undergone a cooling, and that's of importance to agricultural in the Northwest. So what we've seen so far is warming along a bumpy road. The road is sort of, the incline has increased through time. We expect that incline to increase through time in the future, but the bumps won't necessarily go away. So what about this cooling in spring? This is somewhat of a preponderance. And what we've also done is we're trying to attribute regional changes in climate. Why have temperatures in spring actually cooled? And we've done this by looking at multivariate regression, where we've taken known climate predictors, things like El Nino, the Pacific North American pattern, volcanic eruptions, solar variability. And when doing this and running it through a bootstrap regression, what we find is that we have observed cooling. All of that cooling and then some are due to natural variability. And when we actually remove the influence of natural variability, volcanic and solar forcing, we are left with this residual, which indicates what we would see a warming of about 0.2 degrees Celsius per decade, which is very much consistent with the anthropogenic components.
Many of us are using global climate models to give us a picture into what we think, or what the climate might look like over the next 50 years, or 100, into the 21st century. So it seems reasonable then to ask, how well do these models perform when simulating the climate of the 20th century? So that's one of the first tasks we took on, and it's been a fun one, because for one, climate isn't one thing that you can succinctly summarize with one statistic. It's actually climate is many things that I'm not so succinctly summarizing in about 30 statistics, and I'm not even, and there's some statistics I'd like to add to that. But basically what we're doing is we're looking at things like the Northwest seasonal cycle, the diurnal temperature range, and how that changes through the season, spatial patterns across the North Pacific and the Western United States, and there's a bunch of other metrics that we're using to describe how these models are performing. And then we put them all into this big messy table where we've got 30 statistics in the rows and over 24 models across the columns. And there's a lot of information in there, a bit too much to grasp. But that's sort of how our first stab at summarizing how these models are doing. But that's a bit too much information, so we're looking at ways to synthesize that. And some of that information is redundant. Some of that information we have more confidence in than others. So we're working on reducing that. And in the end, coming up for a means of ranking these GCMs, because we're going to take a subset of those in many cases and use those output from those GCMs to run biophysical models or economic models. But I mean, that's fun, but most people want to know what's going to happen. So in addition to how these models performed in the past, we're looking at how these new models are projecting the future climate over the REACH domain. All of them are saying things are going to warm, so it's a pretty good bet that things will warm up by 1.5 to 3.5 degrees Celsius over the next 50 years. Precip's really important in agriculture. That's a much murkier picture. There's not complete unanimous consent among models. As you can see from this figure shows, each dot is the projected change in precip from a different GCM. The different colors show different emission scenarios. And different times of the year. So as you can see, as we've assumed before, that things will get a little drier, maybe in the summer, but we have not very high confidence in that projection. So that's good on the regional scale and global scale, but what we're doing is providing this information that's more usable on a local scale, and we're using statistical downscaling to preserve the regional heterogeneity that's important in our region. And we're also deriving other variables of interest from the GCM data, such as this is percent change in snowfall equivalent. Other things are the length of the growing period and the first day of frost and other metrics like that. So that's the kind of information that's being delivered and probably uploaded to the REACH website. I'm not involved in that, but so that's it. Thank you.